Everybody got notes? I gave you notes. All right. So let's talk about this. So we've been dealing with quadratics. What is a quadratic? A polynomial expression in which the highest degree of the variable is 2. Okay, standard form, ax squared plus bx plus c. And then this is called a parabola. Okay, we've talked about that before also. In a parabola, we have the solutions, x-intercepts, your zeros, your roots. That's where the graph crosses the x-axis. Okay, so that is called solutions, x-intercepts, zeros, and your roots. We have the y-intercept, which you already know is where the graph crosses the y-axis, and then the vertex is the turning point of the parabola, okay? And then the axis of symmetry. See, it's a dotted line because it's not really there. It's kind of like an imaginary line that's there. It runs through, but we don't draw it through. You can if you like to, okay? And it always goes through. And what that does is this point here and this point here are symmetrical around the vertex, around that axis of symmetry. This point here and this point here. Notice this is 2 away from the vertex. This is 2 away from that axis of symmetry. So it divides the parabola in half. Okay, does everybody understand that? All right, so let's look at some key features, and you will be expected to know all of these features and be able to identify them from the graph. Okay, so our vertex, if we look here, our vertex on this one is at 2, 1. Is everybody with me? Okay, the axis of symmetry, this is an equation, so it will always be x equals, because it's going to be that axis of symmetry that runs through the vertex, and so it is a vertical line, so it is x equals, and it's always going to be x equals whatever the x value of the vertex is. Okay? Domain. Now, we've talked about domain before, just a little bit in linear functions. Remember, is domain x or y? It is the x. So it's our x values, it's our input. Remember that when we did functions? So the domain of a quadratic is going to always be all real numbers. So we're going to use it and we're going to put negative infinity to positive infinity because you read x from left to right. And we know when we go to the left, it's negative infinity. Go to the right, it's positive. Because there's not any x values that I could not put in place of x in this function to do that. Does that make sense? It would output a y. So it's always going to be all real numbers unless we're talking about a real life situation. The range is the y values. It is your output. The range is how high or how low the graph's going to go. We read a graph bottom to top. So how far down is these arrows pointing? Negative infinity. And then how far up does this graph go? Nope, look right here. Where does this graph end? At 1. Is 1 included in the graph? Yes. So you will put a bracket, not a parentheses, showing that 1 is included. Anytime you see a bracket, it means that is part of the graph. Okay? So it goes from negative infinity to 1. Okay, what is the y-intercept of this graph? 0, -3. I want your y-intercepts to be ordered pairs. Okay, what is the x-intercept? So 1, 0, 3, 0. Okay, does everybody understand that part? Anyone not? Okay, so let me show you one quick thing. This function is in standard form. Does everybody see that? Ax plus bx, ax squared plus bx plus c, right? Your c, do you see this number here? What is that in this graph? The y-intercept. So this c, when it's in standard form, will always be our y-intercept. So that's another way to check it, or if you don't have the graph, you can see it from the function. Everybody good there? Okay. So let's talk a little bit. increasing interval. Okay, this is always going to be x values. The interval is always going to be your x value. Okay, so I read x left to right. So if I'm over here from the left and I'm coming from negative infinity and to the vertex, is this increasing or decreasing? Increasing. So from negative infinity to 1 with a parenthesis, and I'll explain why in a minute, that is increasing. So that's the interval. That's the part of x from negative infinity to 1, the graph is getting bigger. Does that make sense? Now, where did the graph turn? At the vertex. So at 1, do you see why there wasn't a bracket there? Because it can't be increasing and decreasing at the same point. So we have to put a parenthesis because it's not increasing or decreasing. It's changing from increasing to decreasing. Does that make sense? All right, so then from 1 to positive infinity, this interval right here, 1 to positive, what's happening in the graph? It is decreasing. So from 1 to positive, it is decreasing. Does everybody understand that? From 1 to positive infinity, this interval here, the graph's going down. Here, from negative infinity to 1, the graph is going up. So from negative infinity to 1, what's happening to the graph? It's going up. Does that make sense? A lot of people want to do y's because you want to be like, oh, top to bottom, but this is an interval, and it's an interval using the axis. Okay, is this a maximum or a minimum? It's the highest point, so it is a max. We're looking at the vertex. Is it a high point or a low point? Okay, so it's up here. That's as high as it can go, so it's a max. Good? All right, turn the page. All right, quadratic functions we know have a degree of 2. Okay, the parabola is a U-shaped graph, so it can go up or it can go down. The vertex is the turning point. So the vertex is the turning point. It's either going to be a min or a max. The solutions are your x-intercepts. Solutions are also known as x-intercept, zeros, these are what they're called, or roots. Your graph's either going to open up or it's going to open down. And our solutions are where the graph crosses the x-axis. Good so far? Okay, solutions to a quadratic. A quadratic function can have 0, 1, or 2 real solutions. And we learned that last unit with using the quadratic formula and the discriminant. Okay, if it has 2 solutions, it crosses the axis twice, and the discriminant will be positive. If it's 1 solution, the vertex actually lands on the x-axis, and the discriminant was 0. If it's no real solutions, they don't ever cross the x-axis, and then the discriminant was negative. Okay, so this is 2 solutions, 1 solution, 0. It has to cross the x-axis in order for it to be that.